This is lab 3.2, specific heat, also known as the coffee cup calorimetry lab. These lab instructions, very, very vague. There's supplemental notes I need to give you. Otherwise, there's no way you're going to get this lab correct. Okay, I've already done it a couple of times. So I know here what to add to this thing. The main idea of the lab is this, and you want to write this in your notebook. The main idea is we're going to take a hot piece of aluminum. We're going to heat this piece of aluminum up. We're going to put it into water. Okay, and what will happen is the energy, the heat that's in this aluminum is going to disperse into the water. So that's going to be, we're going to lose energy. That's Q. Okay, heat of aluminum is going to disperse into the water. The water temperature is going to go up, and it's going to again be absorbed by the water. So that's going to be a positive heat of water. So we're going to lose heat in aluminum. We're going to gain it by water. That's going to cause the temperature to rise. And that's the main idea. On the lab, you'll note there's no materials list. So I want you to make a materials list. And here's what you're going to have. You're going to have one calorimeter, which is a styrofoam cup. It's going to look like this. Okay, a styrofoam cup. You're going to have a 100 ml graduated cylinder. It looks like this. 100 ml cylinder. You're also going to have a lab quest and a temperature probe. You're going to have tongs and the aluminum slab. Additionally, you're going to have a beaker, and you're going to fill it with some water. The beaker is going to be 200 mils, 250 mil. You're going to fill it with water. Okay. Okay, let's get on to the instructions here. Measure 150 mils of cold water into your calorimeter. I've already put 50 in here because the graduated cylinder only contains 100. That's its capacity. So I'm going to add the other 100 into my calorimeter. I now have 150 mils in there. Next, so that's done. So my volume in mils of water is 150 mLs. Next, measure its temperature using the temperature probe. So you want to make sure that your lab quest gets turned on, and it might take a minute here. Okay, lab quest is on. I'm going to make sure the temperature, this is just a USB connection, it goes in here. Okay, and I'm going to go ahead and take the temperature of the water, like so. I'm going to wait for this thing to stop, and then I'm going to write down the initial temperature of the water. Okay. Notice there's only enough for one trial here. I'm going to go ahead and encourage you to do 3 trials and then take the average over here. Okay, do 3 trials if you have enough time. If you don't have enough time, then that's fine, but try to do it more than one if you can, and then take the average over here. So my initial is going to be 22.4, 22.4. okay, my final is going to be the final temperature after. Well, let's go to the next thing here. Measure the temperature using a temperature probe. We did that. Place a hot slab of aluminum in the cup of cold water. Okay, notice it says hot slab, but it doesn't say how hot. So here's what you need to do. Put aluminum in boiling water for 2 minutes. Okay, so when we say hot, what we're talking about is to put the aluminum in boiling water for 2 minutes. And I have some boiling water over here on my hot plate. This hot plate is a lab grade plate, so it gets really, really hot. So I want you to be careful with it. I'm going to take the aluminum, put it in the boiling water over here. Okay, I'm going to put it in the boiling water for 2 minutes, and then I'll be back. Well, I'll just put it in there, and then I'll come back to you when it's done. I guess I could also mention that that's what you use the 250 ml beaker for. You're going to put some boiling. You're going to put water in there and boil on this hot plate. This thing gets super hot and it boils fast. How much water should you put in? I don't know. I put roughly, I think 175 is how much I put in there. Okay, just enough to cover the aluminum once it gets in there, but you don't want to put it all the way up top there because you don't want it to boil over. Okay. So about 1 more minute, and then I'm going to put my aluminum slab back into the, I'm going to take it out of the boiling water and put it back into the styrofoam cup. Okay, the slab has been boiling for 2 minutes. I'm going to take it out, and I'm going to quickly put it into the styrofoam cup. And then what you can do, you can also swirl the cup around a little bit as well. Just give it a swirl, and you'll notice the temperature increases fairly rapidly when you do that. Okay, if you have one of those smaller cups, you might have to just be gentle. You don't want to spill the water. Maybe give it a stir with a pencil or a pen or something like that. Okay, basically you want to get it to the point where the water is mixed up well with the slab and it's absorbed all the heat, and then the temperature stops, and then you'll write that final temperature down there like so. Okay, so now that's going to be 25. So now you have enough to do a couple of things here. It says, well, you have enough to calculate the Q value here. You'll do this 2 more times, take the average, and then you can use that for your delta T. All right, so in this case, my delta T, I'm going to pretend this is the average and say it's 25 minus 22.4. Okay, that's my delta T. The mass of the water, well, there's the density of water right there, 1 gram per mil. You can either use that to calculate the mass, or you can weigh the water on its own. And I'll let you figure out how to do that. Specific heat of water, that's this right here. Okay, 4.18. So now you have that information, and you can calculate the Q. You can calculate the amount of heat that was lost. That same Q you're going to use down here as well. Okay, you're going to use that down here because that's the amount of heat that was lost by the slab into the water. Okay, so to calculate the specific heat of aluminum, what you're going to do is you're going to weigh the slab of aluminum and write that down there. You only need to do that once. The initial temperature of the aluminum. What is the initial temperature? Well, the initial temperature of the aluminum was the initial temperature of the boiling water, right? Because it sat in that boiling water for 2 minutes, so it's going to have the same temperature as the boiling water. What's the final temperature? Well, in this case, for this trial, and you're going to do 3 trials again and take the average. For this first trial, the final temperature is the final temperature of this water, right? Because it sat in the water until the temperature is equaled out, so that's going to be 25 degrees. 25 degrees. Specific heat is what you're going to solve for, and that's this guy right there. You'll know the Q value because you'll find it here in this part 1. So you find Q value in part 1, substitute it in. Then you solve for all of these as well. Okay, initial temperature of aluminum, final temperature. And these final temperatures are all going to be the same, right? These will all be the same across. So your only task then is to figure out what those initial temperatures are. And in all reality, it's probably going to be very, very close, if not identical. Okay, we know what the boiling point of water is, but you may want to confirm that just by putting the temperature probe in there once or twice. Once you have all that information, you'll be able to solve for the specific heat of aluminum. And then the last thing we can do is figure out what the accepted value of the specific heat for aluminum is. It's well published, and then you can figure out your own percentage error. Okay, that's pretty much it. Have fun with this.